Hello, good afternoon. Welcome. Thanks for joining us. My name's Lee Biggenden. I'm co-founder of Nephos Technologies. Joined here today with Bob Murphy from Weka. We're going to go through a quick introduction to the Weka parallel file system and how that platform delivers for financial services organizations. Before we get going, I'm going to give you a quick introduction into Nephos and what we do as an organization briefly, before talking a little bit about the market itself, before Bob gives you an introduction into the Weka platform. So Nephos Technologies are an organization founded nearly 10 years ago now to help our customers to solve complex data problems. We're a consultancy-led specialist that really focusing on one thing, and that's data. How do we help our customers to better store, process, protect their information, their data? That approach that we take, that consultative approach, our expertise, has led us to some very consistent growth as an organization from a revenue perspective, with over 700% revenue growth over the last 3 years compound. Also led us to be recognized in the FT 1000 in the top fastest growing organizations in Europe, with an extremely high customer retention rate as a result of that focus as well. And one of our critical areas that we're going to be speaking about today is around data processing and storage that you see here. As a business, we cut across 3 sectors really, or 3 disciplines. Data analytics and data science, so really helping organizations to drive more value from their data in that aspect. Data governance and data privacy. So really that's all around bringing data science to that data governance conversation to help customers I guess get better visibility and control over their critical data assets, regardless of where they are. And the last piece is around data processing and storage. So again, how do we help our customers to remove the data fragmentation that they often experience, to also drive better performance and better cost gains from that infrastructure? And that's what we're going to focus on today. That approach has led us to work with some of the leaders in their field across multiple markets, really, within financial services and elsewhere. Typically, each of these customers want to do something different with their data sets. They want to better store, process, protect that information. They want to transform the way that they're working. And everything revolves around data. So what's the market saying overall? Well, what we're saying is that really data drives everything. That data strategy that organizations have is mandatory really these days. Quite often, and what a lot of organizations are pushing towards is this kind of data strategy that helps to really drive value from their environment. Most organizations believe that's critical to their creating value. Not only that, but also it's felt that only 35% of organizations are actually on course to achieve those goals. So it tells you there's quite a big gap here. And one of the limitations that we believe exists is really around not only the strategy itself, but the limitations that you get from traditional infrastructure. Some of the use cases that we're looking to address there and that we commonly see challenges with, which I'm sure Bob will talk to in terms of where Weka fits around these kind of areas. So things like back testing, quant analysis, anomaly detection, all of these areas that are really used to drive value within your environment. Now, ultimately, for most organizations, it's about driving faster time to value. We want to store larger volumes of data. We want to process it faster, and we want to drive value out of those data sets a lot quicker. And that's really one of the things that we're looking to overcome from an infrastructure perspective. Now, if you consider the legacy approach, if you like, old data, old platform, everything's in silos, everything's got its own storage infrastructure, 3 copies of data for failure protection, very, very static compute, kind of highly tuned for batch workloads, right? And that was fine, but again, you end up with a lot of fragmentation around the data sets that exist. We kind of modernize that. We move forward. We change things slightly. We drive multiple tools, really, kind of modern data old platform. So new tools, faster data, but kind of old approach. So we've kind of developed the application layer, but we've not really improved the storage or the infrastructure layer to cope with that. Typically quite inefficient, lots of silos of applications and data sets. And quite often it ends up a little bit like spaghetti junctions, bit of a UK reference, but with stale data and difficulty moving data between these different application stacks when actually you might want the same data in the same places. Realistically, what we're trying to move to is this modern data approach. We want a single modern data platform. It's dynamic for any workload, it scales, so super agile, and that's both in terms of, I guess, 2 dimensions, in terms of you want to be able to scale out, but also you want to be able to scale outside of the perimeter of your own infrastructure. So that might be AWS, for example. We want it to be highly performant and we want it to be simple. And that's really what we believe the Weka platform gives us, is that ability to have a super high performant file system, to deliver speed where you need it, and to really give you that scale and agility to keep delivering new data services. And that's where Weka comes in. I'm going to hand over to Bob now, and Bob will give you an introduction into the Weka IO platform.
So as Lee said, we're talking about all the use cases in the financial services industry. One of the most challenging ones is high frequency trading. And in this one especially, and in all of these use cases that we'll be talking about, latency is the key issue. Latency kills the objective of what all these financial services use cases are trying to do. They're so much so that their tech stack that they have architected to drive down latency is a major competitive advantage. And often it's the competitive advantage that these organizations have over their competition. As we'll talk about various examples towards the end of the presentation, but they'll be anonymous because, again, these organizations protect their trade secrets as much as possible. Not only is the actual deployment of high frequency trading in the marketplace stressful to an infrastructure, but also algorithmic trading and also developing the algorithms. So basically, before they field a high frequency trading algorithm, they work on the science behind the scenes and do some testing with past market data. This is the back testing that Lee talked about, and then deploy it into the real world. There's a series of benchmarks that the industry looks at. It's called the stack benchmarks. There's one in particular called Stack M3 that focuses on the use cases that we're talking about today. Stack M3 has been out for over a decade. It's used by these organizations to compare different infrastructure components to do the actually to try to wring out as much latency on these benchmarks as possible. I'll be talking about one in particular. It's called the Stack M3 benchmarks. And as you see, these benchmarks being announced, actually, we're right in the middle of another Stack conference right now that's going on as we speak. You see a lot of benchmarks, and most of them are what's called the Antuco data set. That's a 1-year benchmark. It's a relatively small data set. And that's the majority of the benchmarks that you'll see deployed out there. What we're going to talk about today is the Kanaga data set. And as you see these benchmarks being deployed, focus on the Kanaga set for our audience here, because that's the one that focuses on scale. The Antuco set, you can deploy very small single server systems and you can get some great numbers. But the Kanaga set is more stressful and more scalable. They run it amongst more threads and more clients, and it is a great benchmark to test these large scale systems. So here's the selection of large all-flash file systems that are on offer to traders out there. And what I've done is I've taken the stated performance numbers, IOPS numbers from every one of the vendors. It's all on their websites or on their data sheets. And I put them up here. The only thing I did to normalize them, I took whatever they were providing as far as their capacity of the individual component that they were claiming the performance on, and just pieced it together to get a 1 petabyte usable capacity for all the systems here. And you can see this is IOPS, and IOPS is related to latency. The higher the IOPS, the lower the latency. And remember, latency is what we're trying to drive out of these systems. And you can see that Weka does extremely well in IOPS and also comparative latency latency to these other systems. They range from the parallel file systems over here, the Weka and then DDN luster-based system, IBM Spectrum Scale. And then here's the scale out NAS systems that are, a big leg down in performance. One of the things that causes the such a high relative latency of all these scale out NAS systems is that, especially these three here, they all rely on a backend network. So the data that these benchmarks is trying to pull off the storage device actually is behind the server and has to be pulled off either from another server or from another network across a network into the storage server before it actually gets delivered to the client. These parallel file systems over here can serve up data directly to the application, and we'll show that with our example in a second. And that takes a lot of latency out of the system, as you can see. For these Kanaga benchmarks on Stack M3, only these two vendors here have posted numbers in the last several years, and you can see why. Any of these companies that would post Kanaga benchmarks, would just embarrass themselves, so they don't do it. And so what I'm going to do now is actually show you the comparison between the Weka performance on the latest benchmark that we did on Kanaga and also DDN around the same time. And they're also very comparable in size and capacity. So it's a good way of measuring all this. Here's one of the benchmarks. This is called the high bid over varying intervals benchmark. And it's a relatively, it's the smaller version of the benchmark. It's a single threaded. And what the variable is that they do these tests over a data set that spans over a number of years. Again, for the algorithmic modeling and the back testing that goes on in these institutions, they use these longer and longer data sets to test out their trading algorithms on past data. And to do this quicker gives them a competitive advantage over their competition. So you can see red is DDN and purple is Weka, and smaller is better. And this does kind of correlate to the IOPS performance that I showed you before. So IOPS is inversely related to latency. And you can see that Weka is slightly 20%, 30% less latency than DDN on these benchmarks. So that's a good thing that these organizations can look at these two systems and compare them by these industry standard audited benchmarks. And Weka, if you're familiar with Weka, is very into participating in as many audited benchmarks. We're very proud of our system, and we want to, show how good it is performance-wise with as many industry benchmarks as we can, not just in the financial space, but in all benchmarks that we can get our hands on. We really are known for our great transparency and how well the system performs against all these industry benchmarks. Then I wanted to show you a tougher part of this Kanaga benchmarks suite. This is a multi-day variable concurrent requests with varying number of years benchmark. This is the benchmark as you go look down the benchmark. There's 100 threads, 5 years, 50 threads, 5 years, 1 thread, 5 years, 4 years, et cetera, et cetera, et cetera. And this is where more stress is put on this on both systems. And you can see that the beauty of the Weka system really starts to come into play as these benchmarks get tougher and tougher. You can see that we're approaching twice as fast as the DDN example, just because there's more threads, there's more data. So as the load on the system climbs, the advantage of Weka climbs too. Again, purple is Weka, red is DDN, and the smaller number is the smaller latency. And in this business, latency equals money. So you can see that, for an example, this takes over 9,000 seconds to do this, or 9,000 milliseconds to do this one benchmark, and the Weka systems can get it done in half the speed. And again, in this business, I don't have to tell the people in this business, but for others that are watching the webinar, that is all the difference in capturing a trade faster than anyone else trying to get that asset at the same time. So let's go through how Weka is so much performant. It has such a low latency compared to other systems out there. So this is kind of a representation of that tech stack I showed earlier. There's a time series database that's running on the servers in the tech stack. And what's shown here is the architecture and how it's deployed. This database is spread across multiple servers, and they are accessing the Weka parallel file system, which again consists of multiple industry standard servers that we can access in parallel very directly over either an InfiniBand or high-speed Ethernet fabric, and data is pulled off in parallel very quickly, very directly from these clients, which have a Weka POSIX client on them for very fast performance, very direct performance. And we'll get into some of the secret sauce of our networking connectivity in a second that really drive down latency. So Weka has this all-flash tier. These are NVMe populated industry standard servers, all connected with the InfiniBand fabric, all industry standard stuff. And then another unique part of Weka, and we'll talk about some of the secret sauce behind that, is we can also back this up with a very high capacity, very low cost object storage tier that can just store tons and tons and tons of past years data to feed into these algorithms. So first of all, one of the reasons that Weka drives latency down so much is our ability to, when we architected the system, we did it with very, very small block sizes. Our block sizes are 4K in size, and that actually matches the block layout of NVMe SSDs. So our file system was designed around NVMe when it came out. And all the other file systems that I showed you up there, the other parallel file systems in particular, were designed, 20 plus years ago from the hard disk drive era. And they have very large comparative block sizes. The smallest ones for like spectrum scale is 64K. The default block size for spectrum scale is 256K. And that just slows things down as it's being mapped into a small block size device like NVMe. We also have no backend network. Remember before, the data is grabbed directly from these front end servers where the data resides, and that just is able to feed the database so much faster than anything else out there. Another thing that we've done is, even though we're using industry standard InfiniBand and Ethernet networking, we don't use the standard TCP IP services that's available on those networks and what most everyone else uses. We use our own custom way of taking advantage of this high performance network infrastructure and squeeze out the latency of the TCP IP protocol by using DBDK without any context switching and zero copy access. We bypass the kernel stack, eliminating the consumption of kernel resources. And we also implement a proprietary version of the Weka protocol over UDP, which is much more efficient, as you know, compared to TCP IP. So it's a relatively, unknown attribute of Weka and how we, everyone knows Weka, how fast Weka is, but they don't know how we got there. And here's some of the underlying technology that provides the performance that we can deliver. Then another thing that we have, again, this is probably one of the biggest secrets that we have at Weka is everyone knows that we have an S3 object storage backend, are able to take data, or in most people's minds, tier data from the NVMe tier to the object tier, because that's what all the other parallel file systems based on NVMe do. They take data, and as it gets older and aged out, it gets moved by a policy back to the object tier. We do something completely different that a lot of people don't know about. We actually share the same namespace. We do a sort of a Vulkan mind mold with the object storage technology, where this namespace between the two devices is a shared namespace. And so when we move data from the flash tier to the object storage tier, we do it in a way that it still remains part of the Weka file system namespace, and all the metadata stays up here. And this file can be down here. Part of the file can actually be down here and also up here too, based on what blocks are being accessed by the application. So all metadata stays on the flash tier. And to even further optimize performance and lower latency, we actually take large files and chop them down into small files and move them into the object storage in parallel. And that's done on a byte range basis. So we're not moving big lumps of data on a file basis. We're moving blocks at a time, and that lowers latency. And we could also rehydrate parts of those files back to the flash tier based on byte ranges. So we can access very small parts of a file and bring it back across the network very quickly. And that's much faster than other object storage tiering systems. And we could also pre-stage data ahead of time, moving into the flash tier, and also as data gets demoted down to the object tier on the SSD, it's still cached in the flash tier until the flash tier space needs to be evacuated for an application using it. So there's lots of latency reducing features of Weka, even when a object tier is deployed as part of the system. So the other thing about Weka is I just showed you the fact that we can marry a big capacity object tier and a high performance flash tier together in a common namespace. one namespace, one file system, one pool of data. And what that does compared to some of the other options on offer for traders is an example here. This is from the Dell Technologies Algorithmic Trading HPC and AI Reference Guide. This is their reference architecture that they show there. And this is common to a lot of people sees this. You know, a lot of the actually Antuco benchmarks in particular are done on these very fast single server or small number of server environments. You know, a lot of RAM, a lot of NVMe to do the relatively smaller benchmarks, but in practice, at a customer's location, what's typically going on there is that data needs to be ETL'd from some other source where the data resides. And in this case, what Dell and EMC is showing is the various tiers that they have deployed for financial services, and for various different parts of what they're trying to do. And so you have in this case a tier 0, which is very small, fast environment capacity wise. Then that goes off into another tier of fast scratch storage. This is the parallel file systems I was showing you before. PickStore is actually GPFS, and they also have a BGFS option at Dell. And that is kind of positioned as an ephemeral scratch storage system to feed into here. And then for even more capacity and more resilient capacity, they recommend their Isilon environments, or even an NFS based system based on their Dell servers for persistent storage. And then lastly, for long-term high-capacity object storage, they have their ECS object tier. And you can see that the main problem with this, particularly in this industry, is that as data gets moved from one tier to another, that takes time. And this is what is just a killer to this industry. Not only is that, look, I have 1, 2, 3, 4 different systems that the poor storage administrator has to manage. And that's also adds complexity and sources of unreliability to these systems. And again, going back to the advantage of a Weka system is that it's one system, one namespace, no copying from tier to tier to tier. Everything is accessible from the metadata and the shared memory of these two environments. So let's go through a few case studies. We've had a lot of success, obviously, with those numbers that I've shown you and the comparisons with the competition for such a new player. And we've had success in multiple use cases. I'll go through them very quickly. A major quantitative trader does automated proprietary trading. They were using this use case I just showed you of having a bunch of servers with local NVMe drives to do their training models. But the time to copy and manage that data, as we just showed you, was very inefficient. They were moving data from these larger, smaller storage pools into thousands of servers. And that only took time, but it was very complex to actually execute. And also, as you're running various individual applications on each server, some servers are doing more work than others, and the write-intensive workload kept burning out the local NVMe drives. So they implemented a Weka solution, just like what I showed you before, an 8-node cluster. In this case, it was Supermicro Big Twins. We run on pretty much every industry standard server out there, Supermicro, Dell, HPE, et cetera. And they were able to avoid that, all the problems up here. They didn't have to upload data into servers. The wearing of the NVMe drives was leveled out across all the Weka servers, and their performance actually improved 3 times over the individual direct attached storage. And people always ask, well, how could Weka be 3 times faster than the file system in a server? And the primary reason is that, remember that 4K layout of our file system that I described earlier? that is even on a single server basis, that allows Weka to be faster than an individual server with its own local file system. That's the power of Weka FS. The next one is a global investment bank using Weka actually on AWS. So everything I just showed you so far, I guess, is been on-prem. But Weka, the exact same infrastructure, everything from soup to nuts, object storage, S3, using NVMe instances in AWS is available in AWS. And we have a customer doing exactly what I just showed you with KDB Plus in Amazon. They were looking at a solution that was highly performant and nothing that AWS had in their own kit of file systems, including they have a Lustre version, as many people know, was fast enough to do what they needed. So they deployed Weka in AWS, and they were able to get the performance they needed, and also do it in a way that they didn't need a on-prem infrastructure anymore. Another one is a major financial institution, quote unquote. They also had a scale up a single flash array. Those are those devices I showed you on that original chart over on the right. It just took too much time to switch teams sharing that server because they had to copy data in and out of that server. Only one of the teams could use it at one time, and they'd had some problems actually. The individual teams relinquishing the server to another team. You can imagine, people fighting to get, processor time, just like the old days of time sharing. So they deployed Weka, and everyone can run all their applications at the same time. They were able to actually purchase much cheaper servers also, as you can scale out these systems to instead of scaling them up, you can use much cheaper servers, and huge bottom line savings in infrastructure plus the speed results. And then another example is just to show you the depth of our impact in the marketplace. And these have been deployed for years. We're in the capital markets trading firm, huge data sets. This is where that Kanaga performance really shows up. They had poor performance in a all-flash NAS, as you could imagine, seeing the orders of magnitude performance leg down that these all-flash NAS systems provided work versus Weka. They've deployed Weka, and they got a 10x improvement in performance compared to that NAS. And all the numbers I just showed you from before that it bears that out. There should be no surprise in that. And they're able to get all their data done much faster at much lower cost. And I think this is the last one. I think I'm probably using up too much time, but this is a member of the New York Stock Exchange, where most of the trading takes place around the world. Still, the grand majority of it goes through the NYSE, and they're close to that facility. The thing that technique that these people do is they try to park their infrastructures as close to where the data is being traded as possible, and that puts a premium on space and infrastructure and cooling, et cetera, and also to have a proper DR strategy. They've deployed Weka, and in this case, they did a split between flash storage and object storage, and then used we also have this ability to kind of skipped over with the object storage. We can snap that file system to object storage anywhere in the world. And that was just a kind of a low cost, easy to manage DR geo-replicated capability that they've also added with Weka. They were able to increase their performance seven times in this case, and at 1/7 the expected purchase price, and massive cost savings in compute and shared storage, and also a very elegant DR strategy. So the bottom line is Weka does provide the fastest, easiest, most cost-effective, lowest latency performance for this industry. And this is why Lee and I wanted to talk about it. Our only challenge is to get more people to know about us. We're relatively new compared to the incumbents, but the advantages are very clear. And our customers that have deployed this system, this space, as Lee knows, they're the most secretive people out there. So we can't use them as references. We can't talk that much about them. So we have to share the success on our own and get the word out. So you reduce the runtime for the market models. You get more out of the infrastructure. You have the flash performance and also the ability to marry high performance, high capacity, low cost, hard drive based object storage to present huge data lakes of information to their models, and provide that infrastructure agility that Lee mentioned before. That's really important, not just for today's environment, but their trading volumes are growing, and this system is completely scalable. As more trades happen and more models need to be number crunched, we're able to scale out linearly and provide more performance as more resources are deployed in a linear fashion. And that's very unique to Weka. Most other systems out there, as you add more load to the system and you try to add more capacity to the system or more resources to the system, their performance and their reliability actually goes down because of the way they manage metadata, single metadata servers, et cetera, non-scalable, and failover pair servers for high availability. As you add more and more of those, that the likelihood of one of those will fail gets higher and higher. Whereas the eraser coding method that we use, actually, the more the system scales, the more reliable it gets. So that's Weka in a nutshell. I just wanted to close by letting everyone know we, for such a new company, we're the first parallel file system to get on the Magic Quadrant for distributed parallel file systems since they introduced the Magic Quadrant over a decade ago. And we made it as a visionary, and visionaries are defined as people that understand where the market is going or have a vision for changing the market rules. And just a couple quotes that I'll just pick this one here is we talked a lot about performance, and that's great, but probably even more of a differentiator for Weka, and this is what Gartner got from its clients, is they gave us high grades for that performance. But I think even more importantly, particularly with the reputation of some of the other parallel file systems out there, is the overall simplicity of the product and how it's managed compared to the competition. So that is really the performance that we've been harping on here, but really also you get that performance with high reliability and easy management. And that is truly a unique combination in this industry. So that's the end of my talk. Thanks for all the time, and I'll turn it back to Lee to wrap up, and if there's any questions out there.
It's quite an interesting dynamic in terms of the overall structure of those infrastructure systems that we would traditionally use, right? I think for a long time, people have tried to balance cost, performance in one unified, where humanly possible platform. But realistically, there's a lot of bottlenecks in terms of the physical limitations of some of those traditional infrastructure platforms when it comes to scaling up and scaling out. What we often see once you look at the data sets themselves is that, if you take the overall 100% of the data, probably 20 to 30% at most of that is hot. But more and more across every market, not just yours, organizations want to retain more. They want more data. They want more data to process, to look for those patterns, to drive value from. And actually, a massive inhibitor is kind of that traditional model where you have to spend all of your time wrangling data from day to day to try and do that. So what we find quite interesting about this approach generally is twofold. One, you actually get the best blend of performance and cost in this environment, right? So what we're able to do by marrying up the super high performance layer that Weka provides, along with an object tier, it gives us the ability to better map the performance of the infrastructure to the data. So whereas you might have, let's say, 20% of the data set that requires that NVMe level performance, you know, you're going to pay a higher cost per gig in line with that, right? But 80% of the data is slow. It's for all intents and purposes, it's archived out. It needs to be available. Researchers or you know, your analysts may need to get it back to run back testing or whatnot, but it doesn't need to live on high performance NVMe disk all of the time. So actually what this gives us the ability to do is continue to present those data sets up to where they need to be, but leave it in slower performing capacity tiers, object storage in effect, and then promote that up into the performance layer when it's needed. All of that is done automatically without the need for IT to go and manage those data sets and move them around manually on demand. You know, that combination gives us a much better blend of costs because, you know, the bulk of the data is on lower cost, scale out, highly available, highly resilient object, whether it's on premise or whether it's S3 in AWS. But we have the super high performance where we need it. Now, what it also gives us is the, outside of that cost piece, is the ability to scale out both of those layers independently. So as an example, we have one customer of ours, they have around 4 petabytes on the performance tier of data processing that they handle all on NVMe drive, all on Weka FS. 70 petabytes of data sitting in the object tier below it. Now, what they've been able to do over time is really, now that they understand and we kind of help them do this, to understand the profile of their data sets and how it's actually being used, we're able to get a much better blend for them in terms of predictable spend moving forward as well. So they know if they get a dump of data that they're maybe not expecting, that might be a petabyte, 2 petabytes, half a petabyte, whatever it may be, that they've not planned for. In the old world, what happened was they would effectively scrabble around trying to find infrastructure that they could land that data on in case they didn't have enough. What we're able to do in this model is actually have a much bigger capacity tier to make sure that we can always land that data. We do also have, which Bob touched on slightly, the ability to extend that performance layer out into the public cloud. So quite often we see an issue around data gravity as an example. You know, if you've got large volumes of file data that that you kind of want to leverage in cloud, migrating that lock stock or taking a copy of it or whatever it is you're doing into public cloud can be pretty expensive going. And you end up duplicating and replicating data quite a lot as a result of it as well. And what we're actually able to do with Weka is extend that performance layer into AWS, but leave the object tier as is, leave the capacity tier as is. So, you know, we're not kind of, you're not having to move data around and create lots of replicas and duplicates of data that then you can't control and have different cost points and whatnot. We're able to simplify that entire process. Summarize, I think Bob's done this already for me. You know, what we're able to provide here is a super low latency infrastructure that's going to help you drive faster time to value from your data to really support the drive that we all have for more dynamic, more real-time data insights. It's going to remove the management overhead through removing the need to kind of data wrangle, if you like. Break down some of those data silos, and it's going to give you the ability to scale up, scale out as you need it. Really important factors when we're looking at what is a really data hungry world across every single market. So to close, What's next? What can we do? Well, as Bob mentioned it earlier, we do offer things like proof of value testing, road tests, if you like, within things like AWS. As an organization, Nephos have a team of consulting experts really that live this stuff day in, day out. So, you know, we're in a position to have those kind of one-to-one sessions to explore the platforms in more detail, provide demos, whatever it may be to support that, should it be interesting for you.